Okay, the average rate of change of a function is constant for which type of function? Linear, quadratic, or exponential? Ow. All right, you guys got it right. Probably because you only recognize one of the words. But in ninth grade, so second semester, well, in ninth grade, we talk about all of these, but second semester, we will talk about quadratic and exponential functions. Linear is always what? How does the graphs look? Ow. Okay, listen, if it's a straight line, it's linear. So like, could be going up, could be decreasing, could be staying the same. Either, all of these are constant though. It's a constant rate of change. Quadratics are going to be U-shaped graphs. You don't really know about those yet, but they can only open upward or downward. These do not have constant rates of change because you have parts where it's increasing and decreasing. So the average rate of change will be different no matter where you look. Exponential functions are where something either grows at a really fast rate or decays at a really fast rate. And then you could also invert those, but we usually don't see those inverted because of real world situations. But anything that is not a straight line has a different average rate of change depending on where you're looking. Again, the note taking is not out. Make sure we're doing that as we go. Questions? Okay, here's the next one. What is the average rate of change of f of x over the interval 2 less than or equal to x less than or equal to 4? I'll try to make the table bigger. What is the average rate of change of f of x over the interval 2 less than or equal to x less than or equal to 4? Okay, so let's see. Now, average rate of change, what's the formula we use for that? And some of this is in function notation, but like this is still an x. This is the same thing as saying y, so these are y's. And it'll always tell you, because now we're not just looking at straight lines where it's constant throughout, it'll always tell you over what inputs it wants you to look at. In this case, the way it's written, it wants where x is 2 to 4. This is like saying from 2 to 4. So we're using this coordinate and that coordinate. Pick one of them to be x1, y1, the other to be x2, y2, and plug it in. And the way that I labeled it, it would be 15 minus 5, so y3 over 4 minus 2. A common mistake that I usually see on tests is it'll say this question, and people will just tell me that the average rate of change is 10. But like we saw in today's warm-up, you have to divide it by however many the x splits. So it's 10 over 2, which simplifies to 5. That's how much it changed on average per hour. That might not have actually happened. Like it did not increase a whole 5 from year to year, but that's the average. Questions on that? Exactly. So again, take notes as we go. You don't have to write the whole descriptive question down, but just the gist is perfectly fine. All right. So what is the average rate of change of the function shown over the interval 4 less than or equal to x less than or equal to 9? I'll do my best to make it bigger. Sorry. That's as big as it'll go. So do your best. From 4 to 9. Okay, so I know this one was hard to see. My apologies. But if it's a graph, you still look at a certain interval. In this case, it's from 4 to 9. So find where the x is, and it's here. That actually touches the grid line exactly at 4, 2. And for this input of 9, that is here, and that output is 3. Why they decided to zoom out for that, I don't know. But those are your 2 coordinates. And you can do the same thing we did earlier. And label one of them as x1, y1, the other is x2. Plug it in and simplify. So then the way that I labeled it, I'd be doing 3 minus 1 over 9 minus 4, which is 3 minus 1 is, or sorry, I labeled that. I plugged it in wrong. 3 minus 2, which is 1, and 9 minus 4 is 5. Question? You guys know how to convert fractions to decimals? 1 divided by 5 in your calculator. Yes. Question? All right, so what is the average rate of change of g of x equals 7 minus 3x over that interval? I make it bigger. Is have enough time to calculate it. Right, friendly reminder, take notes as you go. So once you put your answer in, take those notes. Okay. So this is one where they give you an equation. So we know that average rate of change is what formula? Table 1, can you tell me? What's the average rate of change formula? Table 1. Okay, so your mind should automatically go to that every time you hear average rate of change. And you know that to use this formula, you need two coordinates. Well, when they give me an equation, they're still telling me what x values they want to calculate the average rate of change of. So the difference with this one is that you're having to plug in each x value. And when I plug in for the x, there's an x, so I'm plugging in the 1, and then eventually I'll plug in the 3. But when it is g of 1, my output is 3 times 1 is 3, 7 minus 3 is 4. So this I can write as a coordinate as 1, 4. That's how we're going to cover it. G of x, when x is 3. Remember, either put that all on your calculator or know your order of operations. What's 3 times 3? And then what's 7 minus 9? -2. And again, you can use your calculator if you want. So now here's my other coordinate. So label one of them as x1, y1, the other as x2, y2. And when I put it into this formula, it is -2 minus 4 over 3 minus 1. Y2 minus y1 over x2. What's -2 minus 4? -6. What is 3 minus 1? And that is how we get the average rate of change is -3. It means it's decreasing by 3 for each one interval of x on average. Good. Any questions? That one's just like a constructed response one on your test. But... Okay, next one. We'll actually see what's still taking notes. Sorry, I actually not. Okay, so here's the next one. What is the average rate of change of h of x equals 2x squared over the interval -1 to 3? And you have lots of time. You have like 2 whole minutes. For 15 seconds. Okay. All right, so it's an equation that you have to plug in these x's into. And let's start with when x is -1. If you use a calculator, here's probably where you went wrong. You probably forgot to put the -1 in parentheses. You do need to put something in parentheses when you are plugging it in always, because it does make a difference. All right, but order of operations, you do the exponents before you multiply. What's -1 squared? Or in other words, -1 times -1, a +1. What's 2 times 1? 2. So yeah, if you use a calculator and didn't put the -1 in parentheses, that's why. Because your calculator said -1 squared was -1 and it's not. Never square something and get a negative. So that's when we plug in -1. When I plug in 3, that shouldn't have been affected by your calculator, but still a good practice to always use parentheses. What's 3 squared? And what's 2 times 9? 18. And then when if it helps you to write it as a coordinate, by all means, these are the coordinates, function notation. And one of them will be x2, y2, and so I don't know why I did it that way. So it doesn't matter. And the other will be x and y. I know this was kind of a lot of math if you're doing it all by hand, but like I said, later for some of it, so I'm it. The way that I labeled it, I'm doing 2 minus 18 over -1 minus 3. You should see the numbers from the same coordinate on top of each other, with the y being on top. What's 2 minus 18? And what's -1 minus 3? -4 actually. Because remember, like we add the opposite. I know that was like the first lesson we did, so it was a long time ago, or just use a calculator. -1 minus 3 is -4. When I divide these, -16 divided by -4 is a +4. Question. Let's take some better notes as we go. So I'll just write what the answer could be. It's just like a bunch of scratch words. And some of it should be. Okay. Here's the next one. And maybe our last one. What is the average rate of change of the function shown over the interval 2 less than or equal to x less than or equal to 6? I'll try to make it bigger. Sorry. I didn't read this. Okay, I already started showing the work. Does it make sense? So we got it. I already looked at your papers and saw who took notes and who took not great notes. But hopefully you're better at average rate of change now. The top 3 can pick a prize from the bin.